Now that we have the reverse unit, the core of the motor removed from the chassis, going to set the chassis aside, the wheels, axles, and chassis. Just a moment to take a look at a couple of other things that is worth visiting when you get it broken down this far. One is the pins inside of a jack panel. Now I have this as a previous video of a common hidden problem. Took me an enormous amount of time to finally find this one. And here's what happens. The pins get inserted into the jack panel, the fiberboard. And what happens is the opening to the fiberboard is very snug, so that when you insert the pin in, it feels very snug, tight fit, and you say, great, the electrical connection is therefore going to be very tight and snug. And that may not be true. That's because these receptacles for the pins have a split in them. And it's possible that that split is too wide, moving the sides of the receptacle too far apart for the pin to consistently touch. What's the characteristics? Gee, Dave, when I move the wires around a couple times and jiggle them, or take the wires here, or take the pins out and push them back in again, and then it starts running, and then it'll stop running, or it's intermittent. Can cause all kinds of problems. The root cause is that the opening of the fiberboard is smaller than the opening of the receptacle. When you push the pin in, it's held tight by the fiberboard. Therefore, you get the impression that the receptacle is holding the pin very tight, and that may not be true. So what I do is, when I have one broken down this far, is I'll go ahead and, of course, the pins have previously been removed. I'll take this one back out, is I take my needle nose pliers and I simply squeeze these closed again. First of all, I clean them, the interior of them, but I just gently press on these to close that gap up. Maybe even tighter on the ends right there. I probably will on this one when I get through. I'll do it off camera. And I use pipe cleaners soaked in 91% isopropyl alcohol to go in and out of these, as well as contact cleaner to make sure they're clean on the inside and don't have carbon built up, so that they're making good contact with the pins. And of course the pins need to be cleaned as well to assure that. And you might even be able to see it here, is that the opening to the fiberboard is tighter or smaller than the opening to the metal receptacle. That took a long time to find that, but once I did, I consistently check these, and what else is consistent is I do not find that this is a problem causing erratic performance in the locomotive. Now once we get inside the brush and bracket assembly, which is right here, I'm going to show you a bushing that Mr. Barker mentions that could be problematic when attempting to center the armature inside the field, but we'll look at that in just a moment. But I want to go ahead and show something that I have begun to look at very closely in diesels and steamers, and that is the centering of the armature, or the centering of the field longitudinally. In other words, along the axis of the armature. This one seems to be very well centered. Notice that the endpoints or laminations seem to align. I've seen these in which the laminations were off maybe by 2 in either direction. And I usually try to improve that by the insertion in a diesel, for example, of new thrust plates, or in a steamer like this with thrust washers. Now, how I test it is simply to grab one of the driver wheels that's connected to the gear axle and just move it back and forth, and seeing how much thrust there is. This one seems to be acceptable. Who knows, that may be why this train has such great performance. Actually, you can see right there in that area the top of that bushing. And if that thing is worn or missing, that means that the armature can move not only laterally along its axis, it can move within the orbit of the field and rattle, you might say, maybe even touch the field, which is undesirable. But we'll check all that once we get inside. I'm going to clean the bracket assembly in great detail. I want to make sure that the brush holders are not carbonized with a lot of carbon buildup. There seems to be some on these. I'm going to make sure they're extremely clean, free of oil, that the brushes are free of oil and the proper length. They seem to be the proper length. However, these springs are measuring at 3/4 of an inch, and I believe Mr. Barker says 1 inch. So I will be stretching these out to get them to 1 inch. Remember the video I did a while back on brushes and springs and pressure is that it's not enough for the brush to be touching the commutator, but without a lot of pressure, because gee, Dave, it's touching the commutator, it's making contact, it's not causing a lot of friction between the two, therefore I should get good RPMs on the armature. Well, according to this scientist that wrote a paper on electrical motors, regardless of whether they're in trains or anything else. Matter of fact, this was not an article about trains, it was an article about brush electrical motors, brush commutator electrical motors, is that there needs to be greater pressure on the brushes so that their contact is consistent. There's less airspace between the end of the brush and the commutator, therefore less sparking and arcing, and the power transfer should be better. Of course, you don't want a tremendous amount of pressure on the brush because you're right, there'll be increased friction. Now let's visit the armature. When I removed the armature, there were 2 space washers on the worm gear end. There could be one or more, none to a couple here, or there could be none to a couple here, near the oil slinger. Be sure to take some sharp object or your fingernails or something and pick on these to make sure that all of them are off and you're not losing any. Because the 2 space washers were here, what I do is I map them to my parts board here, and I marked them as worm, meaning they came off the worm gear end of the armature. Something I'm going to do offline is to clean the commutator with an alcohol wipe, just a paper towel alcohol wipe, as well as the shaft of the armature. This would be a good time to do the test that Hannon recommends to make sure that there is no bar to bar short. These sections of the commutator are called bars, and you can test as to whether or not they're shorting one to another or a bar is shorting to the shaft. It's a great time to do that, or shaft to shaft support. There's a lot of things you can do at this time. I would not toss one of these away just because you think it might be the root. I would look for things like that. Now offline, I'm going to do something that's very simple. I'm going to dip a really sharpened toothpick in alcohol and clean these slots out just by raking them out. Then I'm going to wipe this down, but back on camera, I'm going to show you my preferred method of grinding both a drum and a flat commutator, a disc commutator, with a sandpaper sponge rather than solid sandpaper on a board if you don't have the right tools, which are pretty much the right tools are a drill press and a jig. Cleaning out the slots on the commutator resulted in some carbon dust being removed. You can see some carbon dust on the end of the toothpick, and you can also see some sprinkles around the board right in here where I flicked it out. So there was some carbon. What a large carbon buildup can do in that slot is to cause what is called a bar to bar short, and that is shorting the bars out between one another. So that's being done. Let me clean it up a little bit with some alcohol, and then let's take a look at grinding the commutator. While I had the motor broken down, I went ahead and cleaned the inside of the receptacles on the jack panel with a alcohol soaked pipe cleaner. Also, you can see the bushing for the back end of the commutator, armature is right there. Let's just put it in, and then you can get a feel by just moving it around how loose it is, and whether or not you maybe ought to replace that. This one does have some movement. It's got to have some movement, and you don't want it so tight that it will impact the RPMs. But there's a little bit of movement in there. I think those can be purchased. If you think that could be one of your problems, Of course, this end is going to go into the assembly, the body of the chassis. How worn that one is, maybe it's hard to tell, but just keep in mind that if you see one of those that's just really off or it's flat missing, it needs to be replaced. Another test that you can do is, I know you've all heard the story that some trains seem to run faster in reverse than they do forward. And maybe there's been a lot of theories and cause and effect as to why. But to convince yourself, put the armature back in to the chassis and push the locomotive in reverse. And notice what happens to the armature. It thrusts toward the brushes, which means it provides greater pressure against the brushes. And greater pressure is supposed to be one of the things that causes these electrical motors to run better. And that's brush pressure. When it's going in the forward direction, let's get it back to where it's going in forward, you'll notice that there is some thrust, but it's toward the worm gear end. You don't want it to be so far that it's going to impact that contact, and you don't want it to be so far that the lamentations of the armature are not centered on the lamentations on the field. So that's something you may have to use with trial and error. But once again, watch when it goes in reverse. The commutator thrusts toward the brushes and probably provides a tighter fit. The next thing I'm going to do is grind the commutator to get any anomalies, or at least reduce the anomalies that may be in the surface from years and years of use. You don't want to overdo this. You don't want to underdo it, which is nothing, but you don't want to overdo it. If you want to read about the science of these bars being in the same, having the same planar relationship, meaning they're all in the same plane, then go read Hannon's book. His is an American Flyer book. It's not an engineering book on electrical motors. This guy talks about, from a scientific approach, not a showman's approach, of how this is done and how important it is. Unless you have, or one possesses, a drill press with a jig that holds this, the armature, at 90 degrees, like this, I do not support and recommend that a hole be drilled in a piece of 2x4 and then sandpaper, as lightly grained as it may be, placed on that board, the shaft put in the hole, and then to use the drill press to press down. The drill press and the jig are the only way to go. If you don't have one of those, pressing it into wood, I think, is a risk for getting that planar relationship off, and maybe grinding too far such that you might impact these connections right here, which is what Hannon and I think Mr. Barker recommend, that be very, very careful with those connection points. So I'm going to insert the worm end into my handheld drill. Now, before we move on, we're looking at things like the wheel puller and things like that. You'll notice we're starting to get some cleaned and polished parts, the commutator, the armature. I cleaned the worm gear off as well, with just isopropyl 91% alcohol. Cleaned the brushes, cleaned the screws. And now I'm getting ready to go ahead and make an adjustment on the springs. And I just want to demonstrate to you how I do that, because it's not a just straightforward slam dunk. I simply mark 1 inch on a Q-tip shaft. Now I cut the other end, I snip the other end of the Q-tip off using wire cutters or pliers, anything that will give you a good clean cut right there. And I mark 1 inch on the shaft of the Q-tip. Then I take the spring and just feed it through till I get it on the shaft. Measure 1 inch or stretch it until it is 1 inch. And I find that it's much easier and uniform. You get a much more uniform stretching of the spring if you do it on a shaft like this, rather than trying to hold it in your hand and possibly bending it, or getting two of the springs further apart than any other section in the spring, making the stretching a little bit more uniform. Just keep tinkering with it until you get about 1 inch, and that should be the adequate pressure that Mr. Barker recommends. I'm going to wash the brush bracket assembly, or brush bracket holder, or brush bracket assembly, I guess is even a better way, with the brush holders in it, of course. Gonna wash that to degrease it. It's got plenty of oil and carbon dust on it. Gonna also wash the chassis, wheels, and axles with a degreasing soap prior to spraying it with brake cleaner in order to get it squeaky clean again and to be re-lubricated with not so light an oil. But I wanted to demonstrate again, before I do, what I think is the root cause of this train's erratic performance on the railhead, the starting, the stopping, and other things. And that is the fact that one or more of the wheels is moving independent of an axle in and out laterally. There you saw how easy it was to shift it down. I'm going to pull it up. It's falling down on its own. It's so loose. Look at that. So it's moving in and out. And that's because it was probably over lubricated with a lightweight oil that seeped into and soaked into the area right here on the center hub of a wheel. Now, I was messing with this one just a few minutes ago, just testing them, and I popped one of these wheels right off with my hand. Didn't even take a wheel puller to pull it off. So I'm going to have to pull this one off as well and check it. But I'll use the wheel puller so I can demonstrate its use after I clean it to get these off, so I can check them all so that you can see how it works. Boom, there it goes back down again.